Hey, I'm Mitchell. Welcome to another video in the RSP education series. Think all disconnect switches are created equal? Think again. One wrong move, like using a 2-pole switch when you need a 3 or 4-pole, could mean live wires left energized, blown fuses, or even failed inspections. In this video, we're going to cut through the confusion around 2, 3, and 4-pole disconnect switches, single throw versus double throw configurations, and the danger of assuming your disconnect gives you protection. Spoiler, it doesn't. Whether you're working with single-phase lighting, a 3-phase motor, or switching between a generator and the grid, don't guess. Stay tuned till the end and walk away knowing exactly what switch your system demands and why getting it wrong just isn't an option. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So let's start off with common pole configurations. Let's start with 2-pole switch. It's going to be used for single-phase power, like what's used in homes and small loads. What it switches is 2 hot wires, L1 and L2. Why? Because single-phase power uses 2 live conductors, and both need to be disconnected to be safe. With a 3-pole switch, it's going to be used for standard 3-phase motors and 3-phase equipment. It switches L1, L2, and L3, the 3 hot wires. Why? 3-phase system, it uses 3 conductors to deliver balanced power. You need to switch all 3 together to safely turn off the equipment. So for a 4-pole switch, it's going to be used for systems that have a neutral conductor that needs to be disconnected along with the 3 phases. It's going to switch L1, L2, L3, and neutral. What's a throw though? Throw just means how many places either the switch can send the power to or how many positions it has. For a single throw, that means simple on and off. You either connect or disconnect. For a double throw, you can connect the load to one of 2 sources, like flipping between utility power and generator power. Imagine a railroad track switch. It either sends the train down track A or track B. Same concept, just for electricity. You definitely can't guess this stuff. Getting the wrong number of poles or the wrong throw configuration typically means you might leave a live wire energized, which is a serious shock risk. You could fail an electrical inspection. You could even fry your gear or blow your fuses. Always check your wiring diagram and know your system type. Is your system single phase or 3-phase? Are you switching between power sources? Is neutral switching required? Checklist, let's keep it simple. If you're working with a single-phase load like L1 and L2, use a 2-pole switch. If you're dealing with a 3-phase motor, L1, L2, and L3, you'll need a 3-pole switch. For systems that include 3-phase power plus a neutral, you're going to need L1, L2, L3, and N. You're looking at a 4-pole switch. Now, if you're just doing basic on-off control, that's a single throw switch. But if you need to switch between 2 power sources like utility power and a generator, that's where a double throw switch comes in. Disconnects alone don't provide circuit protection. A disconnect switch, also known as a safety switch or isolator, it's designed only to open or break the electrical circuit manually or with a visible blade. It physically disconnects the power from a piece of equipment so it can be safely worked on. But, and this is crucial, it does not trip automatically if there's an overload, meaning too much current for too long, or a short circuit, sudden massive spike in current. That's not its job. So this is really important because if you just have a disconnect in the circuit and your motor draws too much current, like when it's overloaded, or if there's a fault like a locked rotor, the disconnect will just sit there doing nothing unless someone manually throws the handle. Meanwhile, your motor windings are cooking, your wires are overheating, and your panel's becoming a fire risk. Real world example. Let's say you're running a motor on a rooftop HVAC unit. You've got a disconnect mounted next to it so techs can shut power off when they're servicing it. That's good practice. But if that motor starts pulling, say, 300% of its rated amps because a bearing failed, that disconnect won't trip. You still need a fuse or circuit breaker upstream or integrated within the disconnect switch to sense the overcurrent and break the circuit automatically. Quick recap. 2-pole is for single-phase power, L1 and L2. 3-pole for 3-phase power, L1, L2, L3. 4-pole for 3-phase plus neutral. Single throw, on or off only. Double throw means it switches between power sources like utility or generator. And remember, a disconnect switch isn't a circuit protector. It won't trip during overloads or short circuits. You need fuses or breakers upstream to keep your gear and people safe. Always match your switch to the system. So check the phase, know your conductors, understand your switching needs, and never assume you're protected just because there's a handle on the wall. For a full line of disconnect switches and hundreds of thousands of other industrial automation products, go to our website at rspsupply.com, the internet's top source for industrial hardware.